Assalamualaikum and hello everyone. Today my group and I would like to present our assignment 2 Industrial Power Electronics, which is designing a switch mode power supply SMPS using Matlab Simulation Software. First and foremost, allow me to introduce our group members, beginning with Muhammad Aiman Fikri bin Noor Azman, Nurul Izzah binti Muhammad Nizam, and I, Nurul Ain Natasha binti Ghazali. Next, we move to the introduction. A switch mode power supply or SMPS is an electronic power supply that involves a switching regulator to efficiently convert electrical power. The buck switching regulator, as shown in figure 1, is used because it is a DC to DC converter and a step-down regulator circuit because it is designed to efficiently reduce DC voltage from a higher voltage to a lower voltage. Next, it is the simplest and most common types of switching regulator. And the last one, it can operate in continuous inductor current mode CCM. Moreover, this assignment is to design a digitally controller using a PI controller that is typically used as a compensator that's shown in figure 2. The Matlab simulation software is used to run the simulation and generate the results. The Matlab simulation model was used to create the desired block diagram for providing input to the DC to DC model and collecting model output data. The objective of this assignment is to design and simulate a continuous inductor current mode CCM. Second, to design and simulate the converter feedback controller using a proportional and integral PI controller. And the last one is to analyze the comparison between simulation results and manual calculation.
Assalamualaikum. So I will explain about the simulation. So first of all, we will create a block diagram like this that we are already combined it, and then in the buck and filter we will set our capacitance, resistor, RC, inductance, and our voltage input. So after we set all of it, we will initiate it to find our peak KP and KI. So we use KI equal to 0.025 and KP equal to 35. So from the info we will get our block diagram like this, and we notice that our phase margin is already negative of 35 degree, so it's almost 45, so we will assume it already balanced. And then we will set our signal to 50 volt, and then we will create our circuit. So this is my team circuit. So from here we will set our inductance here, resistor and capacitor here, and then we will run in scope 1 here, scope 2 and scope 3, and then from the result we will get this graph. So we will press the view to separate the graph, and we will get like this, and then we will use the ruler icon to find the minimum and maximum voltage, current or anything else. So we saw here that our switch frequency is same as what we used, which is 35 kHz. And then for the below, this is for the minimum current, and then this we will compare later. Okay, that's all from me. Thank you.
Calculation. First, the VDC that we get in 56.6 and the switching frequency as 55 kHz. For the T ratio, the formula for regulation is V out over VD, which is 0.88. Inductor value, first we need to find the R word, which is P squared over T equals to
850 ohm. For the L, the formula is 1 minus Q times R over 2F, which is 85.71 micro. For L actual, the L min times to 10, which is 0.857 milli. For capacitor value, the ripple values that were given is 0.05. The formula for capacitor is 1 minus D over 8Lf squared times the voltage ripple, which is 0.286 micro. For average current, I is equal to V over R, which is 1 ampere. The maximum current, V out times 1 over R plus 1 minus D over 2Lf, which is 1.1 ampere. For minimum current, V out times the 1 over R minus 1 minus D over 2Lf, which is 0.9 ampere. For voltage output, V out is equal to 0.15 V, which is 8.48 volts. For the comparison, we compare the result for hand calculation and simulation result. First, the inductor current. For the current average, the hand calculation will get 1 ampere. The same goes to the simulation, 1 ampere. Maximum current, hand calculation will get 1.1 ampere, meanwhile for simulation 1.542. The minimum current for hand calculation is 0.9, while simulation 1.146. And last, the voltage output for hand calculation is 8.48, same goes to the simulation in 8.42.
Conclusion and recommendation. In conclusion, through this assignment, students learn to design and simulate a continuous inductor current mode CCM. Next, students learn how to design and simulate the converter feedback controller using a proportional and integral PI. Moreover, students get to analyze the comparison between simulation results and manual calculation. Continuous mode reduces peak and RMS currents compared to the discontinuous conduction mode DCM for the same output power. This maximizes the power capability of the given top switch, increases efficiency by reducing dissipation, and generates lower differential mode noise and higher common mode noise. However, continuous conduction mode may require larger transformer core size, increased primary inductance, and generate high-frequency radiated EMI due to hard switching of the output diode and associated ringing.